So I'm going to start out and talk through a real world example here where we're trying to optimize an AI sales agent. So, when you think about setting up a chatbot that's going to be in front of customers, there's a lot of decisions that kind of go into that. We can capture all those decisions in a feature flag here in Eppo called AI chatbot configurations. So when you set up a flag in Eppo, you can set it up in a lot of different ways. You can set up a basic kind of Boolean on-off switch, which is great for, I'm turning on a new feature, or maybe I want to set up a kill switch or something like that. You can also set up strings where maybe you want to change different model versions or different prompts or something like that. But you can also set up full kind of JSON dynamic configuration variants. So to show an example of that, we have this variation here where we're going to be controlling a lot of different components in how this sales AI agent actually interacts with customers, right? So we have some basic stuff like the provider. In this case, we'll just be using OpenAI. We can specify what model we want to use, in this case, 3.5 Turbo, and then also set up some guardrails like the max amount of tokens that we're going to use for a given request, and then also give some agent instructions here. So an example I'm going to walk through here, we're going to imagine we're selling used cars, which is, I think, kind of a hopefully relatable and kind of fun example. So we'll start out with a very simple agent instruction that says, help this person find a car in a professional tone. And then we can also pass in some additional content assets here. So now this is a set of configurations that we can go use in our application and figure out exactly how we're going to interact with OpenAI's SDK and API. So to show what it looks like to integrate this into your code base, I just have a very simple kind of Django app here that I'll just walk through briefly. But essentially, the integration is really just a matter of calling Eppo's SDK. In this case, we're going to use the get JSON assignment method. If you're using a Boolean, this would be get Boolean. All the flags in Eppo are kind of typed like that. You'll tell us what API, what flag we want to use. In this case, it's that AI chatbot configurations flag I was just showing in the UI. Will tell us what is the subject or the user that this flag is being evaluated for. This will really come in handy as we get into kind of randomized experiments and seeing how that fits into the workflow here. And then you also have subject attributes. So this is anything that might be relevant to the specific user that maybe we want to use for targeting, or maybe we want to use for downstream kind of analysis. So that's really the full extent of the integration with Eppo. From here, when we're actually calling OpenAI's SDK, we'll just pass in some of the configurations that we just got from Eppo. So first we'll check, okay, what provider are we using? Okay, if we're using OpenAI, that means that we should use OpenAI's SDK here. And then we'll go through and pass in, the model that we just specified in Eppo. We'll pass in the agent instructions, and then we'll also pass in any other kind of parameters. This is a very simple use case. Obviously, anyone who's been working with AI knows there's just tons and tons of other configurations and decisions you might want to tweak as you get further into it. But this just for the sake of a demonstration, I wanted to keep it relatively simple here. So now we specified what these parameters should look like. We've installed them into our code base. We can actually look at an example app here. So going back to this, selling cars example, I just have this simple Django app for a fictional company called Rust and Trust Motors. I have to thank ChatGPT for coming up with that name. But if I come here, I can actually start interacting with the sales agent down here, right? So I can say, hi, I would like to buy a car. And sure enough, we'll get a response back. And maybe there's some based on that agent instruction that we gave, it's going to tell us about some of the stuff on this page and kind of guide us towards hopefully a purchase decision, right? So that's great. So far, this is more an OpenAI demo than an Eppo demo. So now let's talk about how this can get a little bit more interesting as we think about changing some of these parameters, right? So the first thing we'll want to do is just specify the change that we want to look at, right? So I can come here and add a new variation. I can add as many variations as I would like. I already have one set up just for the sake of making this a little bit more straightforward. This is actually going to look the exact same as the last set of configurations. The only difference is now instead of saying a professional tone, I changed this to say a friendly, maybe even comedic tone, right? And we can see, does this lead to better interactions with the agent? Does it lead to higher conversions? Whatever that might be. So I'll go ahead and save that. So now I have two different versions. If I wanted to test other prompts or other models against each other, I would just keep adding more variations down here. So now that I've kind of specified the different versions of this I want to go roll out and test, I can come to this assignments page, and this is where you can specify across your different development environments, and then across your different user bases, who should be exposed to which different variation that we just set up. So far, I've just been working in the test environment, as you might expect. And I've been serving this professional variant by default. If I come here, I can change this to that new friendly comedic one I just set up. And sure enough, if I come back to our used car website and I say, hi, I'd like to purchase a car, sure enough, the response will be quite a bit, a little bit more friendly. And in prepping for this, I really got to appreciate how random these systems are because they always come up with some slightly different responses to that prompt there. But now you can see the tone here is quite a bit different. And we kind of feel good that this is actually all working through and changing that configuration as we update this. So that's great. Our local environment looks good. Now maybe we want to go push this up to production and see how actual users kind of react to this, right? So now I'll come up to production, and first thing I'll do is I'll turn this flag on so that we start serving it to any production SDK keys. And now we probably don't want to roll this out to everyone right away, even though we just tested it in our local environment. It's always good to just do a spot check to make sure that this is working as we expect. So what I can do is I can come in here and set up a new rule set that says internal users. They should all, and I can actually use a predefined, oh, sorry. I can actually just come in here and say, okay, if the email matches one of, I think earlier I called it example.dev or .com, then I want anyone that has that email domain to see this new friendly comedic variant. If I go ahead and save that, now in my production environment, any internal user will come in and see this new variant. We can go have one or two people maybe QA this and make sure we feel good about it before we actually go launch it to real end users. Once we've gone through that process, we can come in and do a very similar step where we'll say, now we want to roll this out to a potentially subset of users here again, where we can add all the same kind of targeting logic that we had before. But for now, I'm just going to actually roll this out to all users. So I'll just say all users, 50-50 split. Now, I said all users because everyone will be eligible for this test, but I probably don't want to actually show 50% of people. What if something is weird is happening with the way these models are reacting to that prompt? I might want to start out like much lower, right? So I can come in here and dial in, let's just say a 2% exposure to start. And this will just be a very low risk way to start exposing this new variant to users while being able to measure if there's any major impact to kind of behavior, right? And then over time, as we get more and more confident, we can, of course, ramp this up and get to a full kind of experiment rollout. So that's kind of the next step here. We're now collecting real data. We can go start checking to make sure all the sessions look good and everything. But probably from here, once we're actually comfortable, maybe we want to ramp this up back to, let's just say 100% to kind of move things along. And that's great. Now we're out there and this test is actually live. Obviously, the first question I'm sure people are wondering is how can we actually see if this is moving the needle in a meaningful way, right? So from there, we can just create an experiment analysis on top of this new traffic split, just right through the UI. So let me just call this updated agent prompt friendly tone. I can add a hypothesis here, and then I can select an experiment protocol. So a protocol is a way to pre-register experiment designs. And this is really nice because it means when you're running one net new experiment, you don't have to think through everything from scratch. I can hit this AI chatbot experiment. Like we've probably ran tests something like this before, and I'll actually see a set of pre-populated things here. So some of the background stuff around like what are the configurations in Eppo we need to set up are going to be automated. But also the primary metric and guardrails are always going to be added here. So now any test that's running with this protocol will be targeting this purchase revenue per user metric, but we'll also monitor P95 response time as well as credits consumed per user. So if I go ahead and hit save there, that will take me to a page just to confirm the rollout and everything that we have so far. And from there, I can get to a comprehensive experiment report where I can see some metric results. I haven't actually ran this data pipeline yet, so there's nothing in here quite yet. I'll talk about that in a moment. But I can come in and I can expand on my hypotheses. I can add links to other elements in there, kind of full report builder here, which I'll talk about more in a bit. But let's now fast forward just a moment to an experiment that's actually already running. I've been talking about this agent instruction comparison one, but I'm actually going to switch gears and instead talk about vendor comparison. And the main idea here is that, prompt engineering is cool and there's a lot of value you can drive by testing a bunch of different prompts against each other. But some of the ways to make the biggest swings is to just compare different vendors against each other. We're at this point right now where there's so many companies pushing out new models. There's a lot of price competition for people to, serve the best model at an affordable rate that people can actually scale with. Being able to compare, all these different solutions kind of in real time against each other just gives you a lot more leverage in going and negotiating those contracts, right? Where you can actually see, okay, maybe Llama is more performant than GPT or something like that. And that just for this moment where there's a lot of competition in the market, it's going to be a very important thing to be able to compare different solutions against each other. So coming back to this experiment, then all we're testing here is going to be two different model versions against each other. I'm not putting actual vendor names in here, but you can imagine you have model A from one vendor, and then you're comparing that to model B from another. And you can see this is just a finished kind of version of that report card I was just looking at once we have some actual data populating. And you can see a couple things here. First of all, you can see that the purchase revenue per user is up a lot, right? So it looks like this new model is monetizing at almost $90 more per user, which is great. You can see that it's actually faster too. The P95 response time is just over 6% lower for the new model, which is great. But we also see that the credits consumed is actually quite a bit higher, right? So we're driving better outcomes, we're giving a better experience to users, but at a higher cost. So it's not entirely clear, in this situation, what should we do, right? I think people that have run a lot of tests in the past have probably seen this case come up too, where you have some metrics that are positive, some metrics that are negative. It's a little bit hard to capture what those trade-offs look like. So Eppo will automatically give you some recommendations based on what we're seeing in the experiment so far. So in this case, we have this purchase revenue is up, but the guardrails are also significantly negative. So we need to think about what the trade-offs here and probably have a conversation with more stakeholders before we make a decision. I'll mention that this recommended decision piece here is not something that Eppo is going to come in and be really opinionated on. This is actually tied to that same experiment protocol I was showing earlier. And the idea is depending on your business and depending on the use case within your business, you might want to have different kind of rollout policies depending on what we've seen in a test. So in this case, we have it set up so that if there is a significant increase in your primary metric of revenue per user, and all the guardrails have passed some limited kind of downside risk threshold, we can go ahead and recommend rolling it out, right? Like we feel pretty confident that metrics are moving in the right direction. Where on the other hand, if you have a positive increase here, but some of the guardrail metrics like P99 are potentially showing some downside risk, and the way that we capture this is by a confidence interval that's really wide and it's actually not ruled out kind of negative impacts. Our recommendation is going to be to extend the runtime and just collect some more data. On the other hand, if we have a guardrail that's significantly negative, then we're in this situation where we're going to discuss with stakeholders. But all of these are configurable based off of your use case, right? So if you want to instead just say, no, if there's a guardrail metric that's negative, don't roll this out at all and make that the recommended solution. You can do that. And then everyone that's running a test through Eppo will see that recommendation in there. And that's going to be kind of tailored towards your use case and what you've decided as a company. So that's a little background on why this says to discuss results with stakeholders. From here, you probably want to dive a little deeper in before you actually make a decision, right? In this case, you've probably seen enough here to say, okay, well, I know it's a 17% increase in our AI spend, but it's a 10% increase in revenue. Chances are that's going to be compelling enough to actually roll this out, right? So you can go ahead and do that. I think a couple other checks that are nice before you step into that is to just look at the impact broken out by a couple different things. So we can look at kind of the lift that we've measured by days enrolled in the experiment. So oftentimes, you roll out a new experience, people might engage with it a lot to begin with, but then it kind of flattens out over time. This is pretty promising because, we see a consistent lift in that user's behavior over the entire course of their engagement, with this AI agent. You can also do things like just make sure that there's not specific regions that are being left behind, right? Like if there's something going on with localization, whether that's translation or something else, sometimes certain regions might lag a bit. In this case, it looks pretty flat across regions, so we feel pretty good about that. And at this point, we can probably go ahead and roll that out. So if I come here and hit make decision, you can log why we actually ended up making this. More money is good. And actually go ahead and conclude that test. And that's kind of the workflow, right? From there, we've now launched a new thing. We've seen the impact that it's had on all these metrics and can go ahead and make a decision and roll this out. If we ever want to go back and launch another test, then it's just the exact same process, right? So maybe this test has actually gone live, so we can get rid of that for now. But maybe instead of saying, I want to give this to 100% of users, maybe there's still a little bit of uncertainty in people's mind, right? And instead, we want to do a kind of some sort of holdback analysis, right? Where we say, okay, now for those users, we're going to give, 90% of them this new friendly comedic tone in this case. But then the other 10% are going to keep getting professional. And we can keep that running as long as we want, right? So maybe, now 90% of users are benefiting from this better set of configurations, but we can still compare some holdback group of 10% against that. So, as we observe this over 3 months, let's say, and some big change comes out, we can say, is this actually still as performant as it was before, or has something slipped? And now we think we might want to go back and kind of revisit our decision to roll out this new set of configurations. So that's a bit on the management of these configs and kind of rolling them out and testing them against each other. I think another question that is probably pretty top of mind is how does Eppo know any of this, right? I walked through kind of the setup of adding the SDK and adding some of those configurations into it. And using that to control the experience kind of in real time there. But how does Eppo have any idea what revenue looks like per user, or the percentage of users with referral, which is another example down here? And the answer to that is all based on this warehouse native architecture. So the way that Eppo computes these things is not by having its own definition of revenue, but instead going and running queries in our clients' data warehouses. So that could be Snowflake, Redshift, BigQuery, Databricks, one of those, and computing these things just like you would for kind of an internal analysis. Just to show what I mean by that, if you come to this diagnostics tab, you can see all of the SQL that Eppo is running to actually compute these numbers. And this is all local within your warehouse, right? So you can go test this yourself. You can go see, where are these numbers coming from? It's very kind of anti-black box. And it also means that the setup is really straightforward, right? So when you actually run an experiment with Eppo, the first thing Eppo is going to do is automatically log back some data based on the assignments that we made. So who saw which version of this configuration? You can see a list here where we have this chatbot tone experiment and the different variations that users saw, along with the timestamp at which they saw it, and then maybe some other kind of metadata about them. And that's all actually written back to your warehouse as the main source of truth. Eppo is not going to track this and put it in some kind of data silo. And then when it comes to adding metrics, it's a very similar kind of concept, right? So you'll just say, okay, here's how I compute revenue today in the warehouse. It's the same thing that's probably powering some sort of leadership dashboard or whatever it might be. And you can just add that into Eppo, and then Eppo will know, okay, here's how I compute purchase amount. From there, we'll compile that kind of data pipeline that I was just showing. And then you can also dive really deep into how these numbers are computed and the actual pipeline that Eppo is running itself. So in addition to the kind of simple, like, here's how you pull the numbers, there's also, adjustments we make for things like Cupid, percentile metrics end up having some kind of more advanced math. You can come to this pipeline run history tab and see all the queries that Eppo is running. You can see the individual runs, so you can kind of dive in. It's very much like Finder on Macs, where you can kind of dive into the full directory structure here and say, show me every experiment or every query that was ran, along with kind of query stats. So this makes it really easy to manage if you see a specific query you want to get more context on, you can dive in and see all the kind of stats around it too. So quite a lot of visibility and kind of observability into how Eppo is computing these numbers. And then from there, you have a very low cost kind of deployment of new experiments, very low cost setup of an analysis, because you can just add that protocol and will automatically pull in these data points from your own data warehouse. I think and then the decision making is also even very automated, right? Because we now have these recommended decisions. you kind of automated away almost all of the like human part of the process, right? Of like planning these things and rolling them out and making decisions. The last question is like, how can we go as fast as possible with the analysis itself, right? At this point, one of your main constraints is going to be sample size. Just how long does it take to actually measure the signal that we care about? The way Eppo can help with that, and what we've seen to be very effective, is using a Cupid model. So for anyone that's not familiar with Cupid, Cupid essentially says take some pre-experiment data or some other stuff we know about these users, predict their outcomes, and then look at deviations from that prediction as opposed to just the raw data itself. So if you can model what your users are doing anyways, you can use that to get much tighter confidence intervals and make decisions a lot faster. Uh, Eppo will, by default, build a pretty sensible model where we say take every metric that's added to the experiment and compute each user's value of that metric in the pre-period and use that to predict what's going to happen in the output, or sorry, the post period. So, if a user was a power user beforehand, they're probably going to be a power user afterwards too, and we can control for some variance that way. But we also give you a lot of flexibility to specify your own model inputs there too. So if you go to this same definitions page I was looking at earlier, where we have these logs from Eppo's SDK, this is nice because this is going to track some of the basic kind of inputs that you might care about. But you can also add as much else as you want to this. So I can say like ML predictions or something, right? And I could say predicted purchase amount, right? We can add these other internal model predictions in as additional properties here and use that as further variance reduction. And the powerful thing with that is now as effective as your own internal models are for predicting user outcomes and forecasting that level stuff, now that's going to be leveraged in experimentation too. All right. So this concept is called QPAC. It's a little less known than Cupid, but the main idea is you're controlling for predictions after the experiment happens, as opposed to just the data. You can put in any kind of arbitrary model that you might care about and predict kind of the outcomes there. And then that will give you much, tighter confidence intervals. We've seen some people get like 60, 65% speed ups in experiment results by taking a method like that. So that's kind of that. That's like the floor as I see it at least of how fast you can run experiments because now we've kind of automated a lot of the human parts of the life cycle. We've squeezed whatever data we can out of a machine learning model to make this thing as predictive as possible. And now we can hopefully run dozens of tests in a month and be able to act on kind of all of them. I guess the last thing I'll mention before wrapping this up and opening it for questions is just what to do with kind of all these results. So we also have this insights page where you can go in and build a knowledge repository of all of the experiments that have ran recently. I spun up this workspace just for this webinar, so there's only one example in here. But what you'll see over time is that this builds up and you'll add screenshots of what you're testing. You'll add takeaways that you see. You can link back in and see the full kind of experiment report, of course. And then over time, this is all searchable, right? So you can add tags to kind of go back and look at what experiments we ran in the specific initiative in the past. You can search by team, by primary metric, all that. And the goal here is that over time, you'll build up that institutional knowledge so that you'll have a record of all the things that have changed kind of as you've tried new models out and tried new prompts and whatnot. So with that, I think I'm going to wrap up the demo.